Hello dear students, welcome to chemistry class. In this class we are going to discuss one new concept, that is a Bohr-Haber cycle. Okay. And here in the year of 1919, the two German chemists Bohr and Haber developed a cyclic process for the calculation of lattice energy of a given ionic crystal. Then that cyclic process, which involves the calculation of lattice energy for the given ionic crystal from its constituent elements, is called Bohr-Haber cycle. And according to it, an ionic crystal may be either formed by the direct combination of the combining elements or by the indirect method. And in this indirect method, again it involves three steps. First step is the reacting species. In first step, the reacting species are converted into gaseous state. In this indirect method, we are reacting the involved elements directly, but in indirect method, first we have to convert the reacting species into the gaseous state. From their solid or liquid state, first we have to convert them into a gaseous state. Then second step involves these gaseous atoms are again converted into gaseous ions. Then we have to convert them into an ionic form. Then the last step is these gaseous ions are now combined to form an ionic compound. Correct? These are all the steps which are involved in the indirect method of formation of an ionic crystal. Okay. And now here we can explain the Bohr-Haber cycle for the calculation of lattice energy by taking one example. Here I am taking an example of calculation of lattice energy for the formation of NaCl crystal by using Bohr-Haber cycle. Okay, this is the example. By using this, I am explaining Bohr-Haber cycle. Here we have to calculate the lattice energy for the formation of a solid NaCl crystal, that too by using Bohr-Haber cycle. And for this, we know that for the formation of NaCl, formation of solid NaCl, there are two methods. First one is the direct combination of the combining elements. First one is the direct combination of the combining elements or the direct formation. Okay. And here, when a solid sodium comes in contact with chlorine gas, it will give solid sodium chloride. Okay. And during this formation of a solid sodium chloride, by its constituent, some amount of energy is releasing. That amount of energy we can call here enthalpy of formation. Delta HF is nothing but enthalpy of formation, and 399.5 kJ per mole. This much amount of energy is releasing during the formation of a solid sodium chloride from its constituent particles, that may be the atoms or gaseous molecules, in the direct combination method or in direct formation method. Okay. Then in second one, that is indirect formation. Indirect formation. See here 5 steps are there. This indirect formation involves 5 different steps. The first step involves conversion of metallic sodium atom into gaseous sodium atom. The first step involves the conversion of metallic sodium atom into gaseous sodium atom. That is, the solid sodium is converting into its gaseous sodium form. And the process of conversion of solid into gaseous is called what? Sublimation. The process of conversion of solid into its gaseous form is called what? Sublimation. And the energy change takes place here is called enthalpy of sublimation, or we can write this one SUB, enthalpy of sublimation. Enthalpy of sublimation. And here the enthalpy of sublimation I am writing here in positive sign. Why? Because it is an amount of energy required. The amount of energy required to convert the solid into gaseous. Here it is an endothermic process. Therefore, here I am writing positive sign. The enthalpy of sublimation for the conversion of solid sodium atom into gaseous sodium atom is plus 108 kilojoules per mole. Okay. Then next, second step involves the conversion of this gaseous sodium atom into gaseous sodium ion. The second step involves the conversion of gaseous sodium atom into gaseous sodium ion. That is, this gaseous sodium ion is converting into gaseous sodium ion. Then how we can convert the neutral gaseous atom into an ion? Simply by removing one electron from this one. By removing one electron from the sodium, we can get a gaseous Na+. And the energy change during this one is nothing but the enthalpy of ionization. Enthalpy of ionization. Here, by giving some amount of energy to remove this electron, the change in energy that takes place is nothing but the enthalpy of ionization. Here ionization energy is there, some amount of energy is required to convert the neutral atom into its ionic form. Okay? And that is enthalpy of ionization or ionization energy. And this is also an endothermic process. Therefore, I am writing here plus 496 kilojoules per mole. Endothermic process. Here we have to supply some amount of energy to remove the electron. Okay? It is also an endothermic process. Then step 3 involves conversion of gaseous chlorine molecule into gaseous chlorine atom. The third step involves conversion of this gaseous chlorine molecule into gaseous chlorine atom. And here the dissociation of this chlorine molecule takes place to form its atom. Therefore, the enthalpy change here we can write enthalpy of dissociation. Enthalpy of dissociation. And here also we have to supply some amount of energy to dissociate this chlorine molecule into its atom. Therefore, the energy change here we can write plus 1215 kilojoule per mole. Okay, it is also an endothermic process. Then step number 4 is conversion of neutral chlorine atom into chloride ion. Neutral chlorine atom into chloride ion. How we can convert this one? Gaseous neutral chlorine atom into chloride ion just by adding one electron. Okay, and the enthalpy change during this process is called what? Enthalpy of electron affinity. And here on adding some amount of or some number of electrons to the neutral gaseous atom to getting its ionic form, some amount of energy is releasing, and that energy is called what? Electron affinity energy, or the change in electron affinity of that system, minus 355 kilojoule per mole. And it is negative in sign. Why? Because it is the amount of energy released, it is an exothermic process. Here energy is releasing. Okay. Then last one is combination of gaseous sodium ion and gaseous chloride ion to form solid sodium chloride. To form solid sodium chloride. Here I am writing gaseous sodium ion plus gaseous chlorine ion to form solid sodium chloride. Okay. Then here also in this process we know that according to the definition of an lattice energy, when the two ions are brought from their infinite distance to the adjacent side, they will attract each other and forms an crystal lattice, and some amount of energy is releasing. That energy is nothing but a lattice energy, which we can write as a capital U. Then now we have to calculate this lattice energy by using all these steps, and for this they are developing one cyclic process. This Bohr and Haber developing a cyclic process, and here I can write that cyclic process. First, the solid sodium is combining with chlorine gas to form solid sodium chloride, correct? And this is a direct method, and here the energy change takes place, that is enthalpy of formation. It is there in negative sign, 399.5 kilojoule per mole. Then in indirect method, first this solid sodium is converting into its gaseous form, and the enthalpy change here, that is enthalpy of sublimation, and this gaseous sodium atom is converting into an gaseous sodium ion, and the energy change or the enthalpy change here, it is enthalpy of ionization energy, correct? Then in this side, first this molecule, gaseous chlorine molecule is converting into its gaseous chlorine atom, and the enthalpy change is enthalpy of dissociation, and this neutral gaseous chlorine atom is converting into its chloride ion, and the enthalpy change here, it is enthalpy of electron affinity. Okay. Then now these two are combining together to form the solid sodium chloride, and the energy change here takes place, that is lattice energy, which we can write as a capital U. This is a cyclic process, Bohr-Haber cycle. It is Bohr-Haber cycle, cyclic process. This one is a direct method and this one is an indirect method. Then now by using this cycle or using these steps, we have to calculate the lattice energy of the sodium chloride crystal. Then now we know that enthalpy of formation of NaCl, before this one I will write according to Hess law, according to Hess law, we can say that the enthalpy change is same whether the reaction takes place in a single step or in a number of steps. This Hess law states that the enthalpy change is same whether the reaction takes place in single step, means one step, or in a multi-step. Then by using this Hess law we can write the enthalpy change, that is enthalpy of formation of solid NaCl crystal, is the same as that of the indirect method by adding enthalpy of sublimation, enthalpy of ionization energy, enthalpy of dissociation energy, enthalpy of electron affinity, and lattice energy. By Hess law we can write the enthalpy change is same in a single step or in a number of steps. Then here we have to calculate the lattice energy. Therefore, I want to keep this one on one side, lattice energy U. Then I want to shift all these other on the opposite side. Then delta HF minus delta H sublimation minus delta H ionization minus delta H dissociation minus delta H electron affinity. Okay. Then we know all the values for this NaCl crystal. Then delta HF is minus 399.5. Sublimation is plus 108, but here minus sign is there, therefore it becomes minus 1080 minus 496 minus 121.5 minus minus into minus. Here electron affinity is negative in sign. See here, electron affinity, it is a negative in sign, then negative into negative it becomes positive, then its value is 355. Then on all addition and subtraction we will get 770 kilojoule per mole. 770 kilojoule per mole. This is the lattice energy for the formation of solid sodium chloride crystal. This is the lattice energy for the formation of solid sodium chloride crystal calculated by using Bohr-Haber cycle. Okay. Dear students, Bohr-Haber cycle is a cycle or cyclic process which involves number of steps for the formation of an given solid material, and according to this Bohr-Haber cycle we can calculate the lattice energy for the given crystalline solid, and it involves the direct combination or the direct formation of the solid material and indirect formation of the solid material, and according to that we are calculating the lattice energy for solid sodium chloride, direct method and indirect method, which involves 5 steps. Okay. This is all, and this is the Bohr-Haber cycle. It involves the direct combination and indirect method. Okay. This is all about what Bohr-Haber cycle. Thank you.